السلام عليكم ورحمة الله وبركاته. عاملين ايه؟ يا رب تكونوا بخير دايما وفي أحسن حال. أهلا بكم في كاردياك فيوز. This is Hassan Gamal, nursing specialist, cardiovascular castrations. Today, inshallah, we're going to talk about the ECG. ECG, what's the meaning of ECG? ECG means electrocardiogram. It's a machine used to measure the electricity of the cardiac myocyte over waves. Positive deflection, negative deflection, depending on the monitoring electrode locations and the direction of the electrical activity through the cardiac myocyte. From where this electricity through the cardiac myocyte coming? Actually, as I mentioned before, the heart muscle, it is auto-generated electricity. The heart muscle itself and the SA node, it's auto-generated. The electricity coming from the SA node itself, from the cardiac myocyte itself. Okay, how it's generated? So we have to hold on here about the ECG. First, we have to discuss the action potential in order to understanding from where the electricity coming and how it's move. Okay, so hold on in ECG here. We have to discuss the action potential first. What's the meaning of action potential? Action potential, it's a process of depolarization and repolarization caused by what? Caused by external stimuli. And guided by what? Guided by movement of negative and positive ions, intra and extra cell membrane. So it is negative and positive ions, okay, moving through the cell, intracellular and extracellular. This negative ions movement through the cell membrane, extracellular and intracellular, creating some kind of depolarizations and repolarization. What's the meaning of depolarization and what's the meaning of repolarization? Depolarizations means contraction. Repolarizations means relaxation. Okay, what that ion that's guide the action potential? Ions, which is sodium, mainly extracellular. The concentration of the sodium extracellular is higher than intracellular. And the calcium ions. Calcium ions, the concentration of the calcium extracellular 10,000 times of the concentration of the calcium intracellular. And potassium. Potassium mainly intracellular. It's like the sodium is out of the cell, the potassium like this inside of the cell. Each one ion from the sodium extracellular, he had one positive ions also intracellular from the potassium. So the potassium and sodium, it's very important, two ions to help the cell to be stable for stabilization of the cell. Actually, the action potential of the SA node is different from the action potential of the cardiac myocyte itself. They are different, totally different. Some similarity, but they are different. Okay. But today we will discuss the action potential of the SA node itself. Okay, actually it's four phases. Phase 0, before phase 0, it's the phase 4 of the previous action potential. You will understand with me now. The cell to start to depolarize, it has to reach to minus. Okay, so before phase 0 start, a lot of stimuli will happen to activate the action potential. So the sodium will start to move from extracellular to intracellular in order to increase positive ion intracellular until reach to minus. Once the cell membrane depolarized little bit, depolarized to minus 6, the calcium channel voltage gated will open, and it's slow to open and slow to close. The characteristics of the calcium channel, this calcium channel voltage gated, from the name, voltage gated means restricted by voltage. So what is this voltage? Minus. Once the cell membrane reaches to minus, the calcium channel voltage gated will open, and it is very slow to open and very slow to close. Okay, so the calcium will start to move from extracellular to intracellular until reach to minus. Once it's reached to minus, rapid influx of the calcium from extracellular to intracellular, because I mentioned earlier, as you see in this diagram, concentration of the calcium extracellular 10,000 times the concentration of the calcium intracellular. So once the calcium channel voltage is open, rapid influx of the calcium from extracellular to intracellular in order to increase the positive charge intracellular, in order to make upstroke depolarizations, and this phase we call it phase 0. Okay, as I mentioned earlier, the depolarization means contraction. This upstroke, like you see here, means the cell itself is contracted, maximum excitation. It's excited for maximum excitation. It cannot contract more. So the cell cannot be stay like this. It has to relax it again. Okay, as I mentioned, the calcium channel voltage gated, it's slow to open and slow to close. Okay, if I say slow to open and slow to close, this is not meaning like the calcium slowly movement intracellular. No, the calcium rapid influx through this channel, but this channel itself, it is slow to open and slow to close. Okay, so once the upstroke happens, this upstroke happen, and the cell itself depolarized until positive 10, which is maximum excitations, the cell, it has to relax. To relax it, the cell itself cannot terminate the calcium, and also cannot terminate the sodium, because as I mentioned, the concentration extracellular very high. Once it's open the calcium channel again, the calcium will increase to influx again, and the sodium as well, because the cell has to get rid of this positive charge. It cannot terminate the calcium, it cannot terminate the sodium, but it has to get rid of this positive charge through the potassium outflux. All the potassium channel will open, rapid outflux of the potassium from intracellular to extracellular, to get rid of all of those positive charge in order to repolarize it again, in order to relax it again. Okay, and this phase we call it phase 3. Okay, and you mentioned phase 0, then phase 3. What is phase 1 and 2? Actually, phase 1 and 2, the negative slope, this as you see here in this diagram, is happening very fast, because the potassium fast moving from intracellular to extracellular to get rid of all of those positive charge intracellular. Okay, so phase 0 guided by the calcium, rapid calcium influx intracellular. Phase 1 and 2 happen together at the same time very fast. Okay, phase 3, the potassium already outside of the cell membrane through the potassium channel, voltage gated, to get rid of all of this positive charge in order to repolarize that again. Okay, then resting membrane potential, there is some kind of enzymes, we call it ATPase. خلينا نقول enzymes مركب as you call it. Okay, this ATPase, sodium potassium pump. These enzymes help the cell to rearrange this electrolyte and this ions again. Hey potassium, you are mainly intracellular too, so go again intracellular. Hey sodium, you're mainly extracellular, so go out from the cell extracellular. And calcium voltage gated channel rearrange the calcium also. All of the calcium that inside the cell, it has to go again outside of the cell. So this, to reach to resting membrane potential, the ATPase and calcium rearrange channels, it has to work first to help the cell to reach to resting membrane potential. Okay. Then phase 4, as I mentioned earlier, before phase 0 to start the new cycle of action potential, phase 4, it has to little bit of the sodium go inside the cell again to reach to minus, as you see here in this slide. Once we reach to minus, all the calcium channel will open, rapid influx of the calcium from extracellular to intracellular. Then the cell has to get rid of all of this positive charge intracellular, so it will terminate the potassium from intracellular to extracellular to get rid of all of this positive charge in order to make repolarization again. This happens in each cycle of the heart cycle. Okay, in each cell in the heart, this happens, and cell behind cell behind cell behind cell. That's why this electricity moving through the cardiac myocyte, through the conductive system, from cell to cell, in order to stimulate and help all of the heart muscle to contract, to depolarize and repolarize again. Okay, so this action potential of the SA node. Okay, thank you for watching. If you see this video helpful for you, don't forget to do subscribe and share to receive notifications once we have new video. Thank you.